This conference will now be recorded.
Mick, did we lose you again? I think we just lost Mick again.
Okay, so that booted me.
Okay.
Oh, I'm back. All right, so
All that can explain these parts to us so we can go straight to them.
thank you everyone for attending. The quick agenda for today is I'm hoping everyone has been able to have a quick look or has heard the presentation on what this workstream is about. So we're dealing with hardware management for liquid cooling. What I wanted to do today, because we'll be working closely with DMTF Redfish, I wanted to get a couple of people in to just give us an overview and an intro of what that is and how that's going to help us with this work stream. So I don't know if I'm able to do it, but I'd like to make John from Intel the presenter. Rolf, is that something I can do now?
You should be able to.
All right, let me go.
Yeah, it should already be presenters.
Oh, there
Do
you
you see the slide set? Okay.
Yeah, it's coming up. So John's going to give us an intro on Redfish and the OCP profiles that is going to be one of the outputs from this work stream. So there we go. All right, John, so take it away. Thank you.
Okay, thank you. So I and Jeff are both from the DMTF, and I'm just going to give you a high-level overview of what Redfish is and why it's important to DMTF. So before I do that, I usually talk about standards in the process. So there are these organizations, and some of them describe, some of them prescribe, some of them implement, and then some of them conform. So the duty of description is to specify the standard, and they go out and seek domain expertise to expand the standard. The problem is the standard continues to grow, and the logical question becomes, do I have to implement all of it? You don't. You have to go find someone with domain expertise in a specific place, like OCP, for data centers, and they can prescribe a subset of the standard that needs to be conformed to. And these prescribers is what I call prescriptive power, because they appear in RFPs, and RFPs drive the money, and that's when they begin to ask, what do I need to do in order to meet the requirements for this RFP. And once that's done, we have implementations that go off, system integrators, engineers, and then when they deliver a product, and then we have to go verify that whatever was prescribed was actually conformed to at the end state of the product. So with that landscape, we figure out, okay, what does everyone fit? So the DMTF and SNIA for storage define standards. So we keep on growing the Redfish standard to manage more and more domains. Prescription is OCP, the Open Data Center Committee from China, which is the counterpart to OCP, the open group who does process automation for the automated factory. Next is implement. Yes.
Sorry, John. Is everyone else seeing a screen? Because I'm not seeing any presentation at the moment, John.
Yes,
I'm seeing it.
I see it. Yep.
Yeah, I'm seeing it. Yep.
All right, awesome. Sorry, I just had to
Oh,
check.
Mick, you're really screwed today, aren't you?
Yeah. Carry on.
Mick, if you don't mind, you can sign out and try and verify your credentials in your GoToMeeting app and sign back in. If you're familiar with the content, we can keep going.
Yeah, I'll drop out and I'll come back. I'll try and fix it. Thanks. Carry on.
Sure.
And Mick has a copy of this. I sent it to him earlier.
Yeah.
So
I'm familiar.
within implement, there's OpenBMC, which is open source implementation. There's a version from the Linux Foundation, and there's a version that AMI has contributed to OCP called AMI Megarack Open Edition. So we have three parts of this process in place. So what the DMTF saw was there was an issue with the back end of how do we actually describe something or prescribe something so that it's the requirements are well understood. So we invent this concept of a profile. So a profile is a JSON file which defines the requirements for the model, both the model, the values of the model, what resources have to appear. And that would be owned by OCP. And what the DMTF would do was write a redfish interop validator which consumed the model on the profile, and then auto-generate the test, and then ran it across a conformant platform. And then, so this has been embodied in the OCP kind of contribution flow, so that the output of these tests, the test results, are actually attached to the products as they are contributed to OCP. Any questions? Okay, so with that flow, OCP, DMTF has very limited expertise. We're experts in servers. We do server management really well, but as far as the other management domains within the data center and in without the data center, we have sought alliance partnerships with other organizations with far more expertise than we have. So for storage, we partner with SNIA to do Swordfish, VME Express, and Open Fabric Alliance to do VME over fiber. In the DSIM space, we've have alliance partnerships with ASHRAE, OCP, and the Green Grid, all to understand what happens at the periphery of the data center, which have nothing to do with compute. As to highlight that, in 2017, we created a work registry with ASHRAE Technical Committee 9.9. The link is here as to exactly what the work registry was, but basically the focus was to make sure that the nomenclature for metrics and telemetry was reflected in the DMTF model, so that there wasn't a confusion as to what was what as far as properties were concerned.
John,
And then after, yes.
sorry, just which year did you say again, ASHRAE? Was that 2017?
I believe so, yes.
Okay, thank you.
Yeah, if you click on work registry, it's the top line as to when it was created.
Yep. Oh, there it is.
Okay, and since then, we were approached by the Open Group Open Process Automation Forum. They were looking for a interface to manage the automated factory above OPC UA, which is what they're currently using now. They've chosen Redfish. They released their specification about 3 years ago and has been pushing that through the industry. And then PicMic picked up Redfish to do industrial IoT, and those are still that's still in process. And their issue is that in IoT the controllers are very, very small. So their main focus is how do I get a Redfish implementation into a very small controller. So this is to reflect that we've taken Redfish as an interface that's been internationally recognized, and we've expanded it with our partnerships with other standard bodies to expand the scope that Redfish can manage. Any questions? Okay, so what does this all mean to OCP? So in 2018, OCP committed to use Redfish as their management interface. The concept was that we would create a baseline hardware management profile, which would be a common set of manageability across platforms. So if you found an OCP platform, you didn't have to ask what type of functionality can you have, and are they different between server and storage. So there's a common set, and then based on that common set, each platform group could extend upward. So servers could add additional resources that were unique to server platforms, and storage could do the same. And then finally above that, we said, well, we have now all these OCP platforms that support some version of Redfish. Can we design a rack manager that manages a rack full of platforms that support Redfish? And for that, we now have a open rack management controller profile for managing racks in the rack manager. And so you find these are all accepted by the IC, both the baseline, the server, and the rack management profile. So they're released in tandem. They release both the profile, which is a JSON file, and then a user's document, which is a Word document about how you, for each use case, how you interact with Redfish to get the information that you want, whether it be a firmware update or resetting the system and so forth. It's far more approachable than trying to understand the JSON syntax. Any questions? So we've been working with various other platform groups as they are okay with writing profiles that we would help them extend into the particular platform domain. So storage has been actively looking at extending the baseline. Okay, I think this is the last slide. So one thing, as I mentioned, is that Redfish is public. We've been looking at we've produced a lot of open source for interfaces above the Redfish interface for clients. So the DMTF has test suites, Python libraries, Redfish tool, which is a command line interface. SNEA has also added their emulation, and they have integration to PowerShell, Power BI, and a sample website. There's been Golang libraries. So the industry has been pretty active in saying, okay, Redfish is here. How do we ease the creation of client-side implementations? Yeah, and that's it. So are there any questions to that? If not, I'll let Jeff Otter dig into the details of the Redfish and its models. Okay, Jeff, it's all yours.
Thanks, John.
For the record, I thought it was a very clear explanation. Thanks for that. Gave me a lot of insight. Do I need to make somebody a presenter?
Yeah, if you can make me presenter there, Rolf. This is Jeff.
Right. Okay, while I'm doing that, Mick, are you back up and running now with audio?
Yes, I'm back dialed in.
All right, cool. You should be the presenter. Yeah, there you go.
All right. Thanks, Rolf and Mick. Hi, everyone. My name is Jeff Otter. I'm with Hewlett Packard Enterprise and also co-chair the Redfish Forum, which is the working group within the DMTF that owns the Redfish spec and all of its related activities. So I wanted to go through a kind of a top level of, and I hope that at least the folks, if you're on the call, that you know what Redfish is. I'm not gonna, I don't have a whole lot of introduction on what the spec and the standard is, but just in case you're not, it's Redfish is a management management protocol and data model. Those two pieces are defined separately, but it's all based on the RESTful design methodology for doing network-based management of really any device. So the protocol is nothing we invented. It's HTTP and HTTPS, and uses the JSON data format for the transport. And then the bulk of the work in Redfish is defining the Redfish schemas, which define the JSON payloads that you get from all the URIs that are presented through a hypermedia connected resource tree. So and hopefully that was, if you're not a computer science person, then that probably was not a helpful introduction. But suffice to say, the goal of Redfish was to get get a human readable and something usable by script level or operational technology folks, or DevOps, is what we call it, DevOps, and not necessarily software developers, but it's both human readable and machine operable. So if you have more sophisticated things than a simple script, Redfish has enough strictness to the definitions that you can programmatically operate and run through run through the model and the data, in automatic fashion. So there's the quick intro. So as John said, since the spec came out in 2015, the protocol has not changed much. There's been some functionality added to the spec in general, but the bulk of the work has been expanding both the depth and the breadth of the data model. So as it started with servers, then kind of continued to flesh that out to really have pretty complete coverage now of any topics related to server management. And then we branched out, realizing that the other devices in the data center, from a management perspective, they share a lot of common housekeeping functions. Once you stick an Ethernet interface and want to remotely manage something, you need accounts, you need security things, usernames and passwords. You have to have some kind of event delivery system, ability to do update firmware, install licenses, et cetera, et cetera. There's an awful lot of stuff that is common to all managed devices. And then you have the actual, domain specific knowledge or tasks, and that's the new parts. So what came to be was that since a lot of the work is common amongst all those devices in terms of what the user tasks that need to be performed, you can apply the same thing we did for server management. So we've already fleshed out, how to do firmware updates over the network, how to do account management, certificate installations, license management that was recently added. So why not, leverage all of that and make that common for both the implementers on the service side, but also on the client side. I have one tool that could update firmware on, can deliver firmware image to any of the Redfish enabled products. So, why continue to reinvent all of this stuff, for each individual product category, or worse, each individual vendor. So that's where the ecosystem kind of came. And boy, it's a lot easier to manage a bunch of disparate devices if you don't have to switch tools and protocols. All you're doing is really pointing the tool at a different IP address or a different URI and getting data that is self-describing and that you can go operate on. So there's the long-winded introduction to what we're doing. So what I've got on the screen here, and let me put in the chat here so that just to make it real simple to grab. So I'm showing the presentation here, but let me click over here real quick. So this is the DMTF's standards page, and the document that I'm showing here, and I think we've got it on the OCP site as well. But all of it is contained in this work in progress bundle. This is the link I just put in the chat here. So this is the data center infrastructure management bundle. And so that's everything I'll show here today is in that single file, that zip file that has the presentation, this guide docs that I'll get into, as well as a couple of mock-ups showing what the data looks like for an implementation of a cooling unit. So the path that we had started down, actually several years ago was to get into the data center infrastructure products. And we have shipped models for power distribution units, and those have been implemented, in the wild. So we know at least they're at least operable. And from there, we've expanded out now, trying to do the same for the thermal equipment, or more specifically liquid cooling gear, as an area where there's an awful lot of work going on. And not a lot of not a lot of previous standards for management. So that's it's kind of a greenfield from our perspective. It's a good place and ripe for opportunity of producing a standard where there's not a lot of legacy friction that gets in the way of that. So so what we've been doing, the DMTF has been working with some of the vendors, the subject matter experts. As John said, we have enough expertise in the data models, but not so much in the gear. So that's what limits the speed at which we can produce the extensions to the data model is having enough experts around to to check our work and to help us with all the description text and then what data needs to be provided. So we've been doing that for a while, and just very apt timing here with the elevation of all this liquid cooling pieces to in the OCP to be a top level project, because we've been working with the individual teams to try to get data models for redfish done for this type of equipment. So let me show you what we've come up with so far. And as I said, this is all work in progress. And the thing to know, probably most important about the redfish spec, is because of the way JSON and all the data model and the stuff works, it is easy to add things over time. It does not break any compatibility. It doesn't have any of those kinds of issues where where previous standards had very rigid data structures. JSON allows us to add things over time, and it doesn't interfere with anything. So we do it all the time, and if you look at all of our data models, you see that they're all individually versioned, and so they grow as as they mature. So what we're trying to do here is get a model that is at least sufficient to describe some equipment. We want to make sure that it can comprehend as much gear as possible, but it doesn't need to be complete for us to declare some success and put a 1.0 out, because we can continue to flesh the model out and add more functionality over time. And we found that as long as we have a model that that can comprehend additional gear without breaking, it's been a much more productive form of operating by going out with the version 1 and then keep building on things, because if you don't get any adoption, we could be here for 3 years deciding what the fifth property is supposed to be called. So okay, let me pause there just in case there's any questions. I've been going for quite a while here. Okay, all right. So let me show this work in progress pieces, and I'm going to do this kind of at a high level, and I'll show. Let me click over here real quick. So in that bundle, there was also a document called the Redfish for Thermal Management white paper. So this is also obviously this is all based on the same work in progress. What this document is, if you're familiar with any redfish pieces, this is actually a subset of our schema guide, where we take the schema files themselves and then process them with a documentation generator to create a user guide that is readable by mere mortals. So if I go and just click on these things here, what you get is for each of the schema definitions, it becomes a guide here showing each of the different properties that are defined in the schema, and then showing their descriptions and their data types and so forth. And then there's examples of what they look like, on the wire. So it's an easy way for folks that are more subject matter expert and less JSON or less data model experts to look at the data and the definitions and see if this makes sense. And that's really our ask here is are we on the right track, and help us course correct to either change what we've got or continue to help flesh it out. So I encourage folks to look at this, and that document is in that zip bundle that I put in the chat. Okay, so I've talked about that. So so the models that we have so far, this is really based on trying to come from practical examples and then work backwards into generic data models that can apply to any piece of gear. So we started with again, trying to be practical, starting with something that looked like a rack-based cooling distribution unit. With Mick's help and some other folks, there have been a lot of interest in the immersion cooling area. So we've also created models or mock-ups that show how the model can also apply to those types of equipment. We don't cover, we have not really modeled the air-based cooling in the gear in this yet, but we're trying to be mindful of that and make sure that it either fits in the model or can be added as an adjacent part of the model. The general style is stuff that we adapted from what we had learned through doing the power distribution units, since they do share a lot of things in common. just the molecules are a little bigger than a single electrons, but otherwise they have a lot of the same concepts. The nomenclature, of course, is completely different. So let me get in and let me show that sort of the general model of this. So we branch off of the top level of the data model, which is called the service route, and then define new schemas down underneath a resource called power equipment, which is effectively gathers all the links to all of the gear that may be that's managed from this device. And so this is kind of the structural elements of Redfish, and is there really for the purposes of device discovery. And so within that power equipment resource, you will get linked, and these are the kind of the different categories of gear that we've identified that need to be described here. They share a lot of commonality and definition, and so there's really only two pieces underneath here that I'll show. There's literally a generic schema called cooling distribution, and then another one for defining a cooling loop. The immersion cooling is a variation of this. I'm sorry, I said two. There's three. So we expect that there will be something that would describe an air handler unit, and whether or not that looks like the CDU or a completely separate thing. They would certainly share a lot of common definitions. So here's this bubble diagram, which looks really messy, but let me take you through the. It's not as bad as it looks. And I'm missing the top arrow here, but so any client comes into the Redfish service route, and I said this is really for the purpose of device discovery. From there, they navigate and find that there's a thermal equipment resource that now describes any of the cooling gear that is managed by this instance of the service. So and I'm showing here there's kind of two that would be part of a rack CDU. One is a cooling unit, and you'll see these blue bubbles are what we term in Redfish as a collection, which just means there can be one or more of those devices. Because this could be a large system or a large management proxy that could be managing multiple CDUs. And so that's all supported, at Redfish from day one. So, I can manage 5 different units from one IP address, for instance. So you'll see that these concepts of, well, there's always a collection that allows for one or more of any of these things. Now in practice, we hope that each of these devices probably gets their own IP address and their own its own Ethernet interface, so that you have so that there's that more standalone product. But anyway. So the cooling unit is the main part of the model. So that will have all of the core information about the unit, and then everything else underneath that cooling unit is effectively one of the managed subsystems. And that's where it provides all the flexibility for for the different category or the different types of implementations or how complex that unit is. So if I kind of run through the different subsystems. There are cooling loop connections, or there can be on both the primary and the secondary side. Obviously, there can be a power meter that matches into the joule piece, but that's for looking at power measurements for the unit itself. And then there's the additional gear that supports that cooling unit. So there can be one or more filters, there can be one or more pumps, and there can be one or more reservoirs. And then each of those, each of those are collections. So underneath that, I can see here we've got, I've got a primary and a secondary side filter. I've got one pump and one reservoir. So that's kind of how the model lays out. And this is all intended to be functional views of the gear. In Redfish, we have a separate view, which is a physical view, and so that's represented by what's called a chassis. So in the case of a rack unit or a CDU, you've got some piece of sheet metal that encloses that, has the has the vendor's name and sticker and support number on it, and a serial number. So there's a link here between the functional and the physical model. So there's some chassis instance that would describe the CDU. And then lastly, the other kind of the dotted lines here are trying to show links across the model. And then lastly is the cooling loops, which are separate entities because they provide connectivity amongst many pieces of gear, and so they have their own model. And then we have links to show that, hey, this cooling loop over here is part of rack number 7, as it says. And so the connectivity there between the CDUs and any of the gear that are connected to that loop, those are all shown, over here. So let me pause there. Does that make sense from a model? Is that folks following me?
I can add to that, Jeff.
Please go ahead.
For context for everyone, one of the outputs of this workstream, as we said previously, is to augment and get full coverage for all the liquid cooling unit for OCP, right? So that means that, this model, we've got a cooling unit, so we need to make sure that cooling unit can represent a door heat exchanger, for example. And we also need to make sure we can represent cold plates and the ACF, some of the ACF, like waterside economizers, stuff like that. We have to expand, augment this to cover those cases so we can do an end-to-end OCP coverage, including the inputs and outputs, or the cooling loop collections, as Jeff just called them. Plus heat reuse. So we might need to be able to model an external user of the heat, and then their return line when they hopefully give you back cooled liquid as they consume the heat. So I think Jeff mentioned this was based off work with immersion cooling units late last year. So we think there might be 80% coverage, but like I said, the scope is to expand this and make sure we cover all the different liquid cooling units and their interconnects and their asset information, their events, their alarms that they might spit out. Okay, sorry, Jeff, I think you were trying to ask general questions, so open it back up to general questions.
I think that's valuable explanation, Mick. I'd like to add to that as well, that also within the different technology domains, whether it's cold plate, radar coolers, or immersion cooling, there's different styles and different ways of dealing with those. You've got rack-based immersion, for example. You've got open bath immersion with or without pumps, and there are different methodologies out there that address different types of IT equipment or operation models. And I think here the vision here is to come up with a schema that is ready for all.
Correct.
Yep.
Yeah, because you might have a standalone CDU, you might have a built-in CDU, you have the rear door heat exchanger is an interesting one, like you said, because that's going to be inside another chassis, which is the rack in terms of modeling. So we've got to look at all the different ways you can join these together and build a liquid cooling unit.
Okay. So I'm going to skip around a little bit here because I think that to build on your comments there. So looking at the basic the starting point for the cooling unit itself. And oh good, I got this on the slide. So and again, this follows what we had learned from doing the power distribution unit is that there's many types of gear that have different levels of functionality, or may have things like battery backup, for instance. Well, that's a UPS, not a PD. Well, they share an awful lot of stuff in common, and so from a management standpoint, if I want to flick the power on and off on an outlet, I don't care if that outlet is on a PDU or a UPS. That switch should look the same, to the end user. So that's the kind of things that we do. But there's a need to know, or there's a like to know. So if I'm just to continue that analogy, if I'm trying to bounce power on a piece of gear by turning the outlet on and off, Yeah, I don't care. I don't need to know if that's if that outlet is controlled by a PDU or a UPS or some other piece of gear. I just need to be able to operate it. Now, if I want to know, because I'd like to figure out if which of my things have battery backup, well then I need to be able to go find out those differences. So that's kind of the design tack we take is only force the user to know things that they absolutely have to know, but otherwise it can be discovered, but otherwise can remain effectively invisible. So the way that we do that is trying to unify these schemas across the various classes of equipment that all share let's say 80% of the stuff in common, and so at least what we've got so far is that that a cooling unit's probably got about 80% common. So we have that, and so that need to know is not that I don't need to know those differences until I get down into some of the gory details. But if I want to know, we almost always have some type of type property in the schemas that can tell you to give that classification, and that allows the folks doing coding on these things. They can do their kind of their switch statements on the oh, okay, well, if this is a UPS, I want to do this, this, and this. So in this type, we have we have definitions for this equipment type of things like a rack CDU or an immersion unit, and so forth. So there's, I probably have a list of them on another page here. But this is something that we can use to help to explain what is it that I'm looking at more specifically than just a generic piece of gear. So the cooling unit, this schema contains all of the general product information, so make, model, and serial number, hardware, firmware version, date of manufacturer, that stuff's all there, and then provides all the linkage to all of those subsystems that I showed on that bubble model. So that you can discover what's available and what functionality has been implemented there. So so picture worth 1,000 words. Here's a very compacted version of that the JSON payload for this, and it's been formatted to fit on the page. When you look at it, it'll be a little easier to read. But you can see even if you know nothing about Redfish or about JSON, you can probably look at this text that you actually could pull up in a browser. From the implementation and tell me what the firmware version is on that CDU. So I mean, just in case, there it is. So that's the style of Redfish, is to try to make both this is all key value pairs, but try to make the key names human readable, and then obviously the values are trying to obviously also trying to do the same thing. So there's not a lot of other, you can see here, there's a bunch of these links, and I abbreviated them here to fit on the page. But you can see that this, that this is a pretty well instrumented, piece of equipment, so it has an awful lot of subsystems here that you can go look at. So let me move on here. So the other main concept in the model here is the one of the cooling loop. And so, as I said, this is, this may be, purely a software construct, in the management pieces, to be able to show the connectivity. I'm not necessarily thinking that if it's just a big pipe running around the data center that probably doesn't have an Ethernet interface on it, but I can still model that somewhere, in some piece of gear that allows me to document all the connectivity, so that software can model that whole loop and follow the flow, but both from the sense of the cooling unit, and also from a fault domain, what gear is attached to this, and so forth. So we're trying to enable the DSIM level software to start to do really interesting things with all the information, and on both the cooling and the power side, being able to trace the flow of those effectively those loops through the data center, making sure, to know what things are connected where, and then be able to use that information in an interoperable fashion to go make some more interesting decisions about, how load is allocated, and efficiency, and so on and so forth. So that cooling loop, okay, some terminology details here, but again, these are our terms. I'm happy to change anything to make it more obvious to the subject matter experts. So we at least have the concept of primary and secondary loops. So coming into this very simple diagram here of a rack level CDU. So primary cooling coming in from the data center enters the CDU and then is then pushed out through whatever means to feed the individual systems that are being cooled. So the cooling loop model describes both the physical aspects of this, the connectivity, showing what things are attached as either producers or consumers of that cooling, and then provides a lot of data points for monitoring the temperature, pressure, and flow rates and so on and so forth. And just as an example here, let me just punch in here. So I want to leave a few minutes here for folks to talk. So this is a good example of a more detailed schema view, resource view, because it shows, this is a cooling loop, but you can start to see that we have all these normalized values and reporting for the various metrics that come out of this class of equipment. So here is temperature, pressure, flow rates. I think I've got some more on the other pages, but anyway, that's the kind of the detail. And like I said, I don't want to go through all the details here, but you can walk through the slide deck to see as we get into the into the individual pieces and how they get described. How all the data looks, has a very similar style to it, but also shares a lot of common definitions.
Okay, so Jeff.
Yes.
Can you quickly go back to the rack slide with the rack CDU for a second?
With the bubble diagram or
I think it's 10, number 10.
Okay.
Yeah, so this is a good example of where terminology may differ that we have to work through together, in that these primary cooling loops and the secondary cooling loops, from what I can gather, and people can correct me if I'm wrong, one of those is the ACS and the other one would be a DECS loop connections. Is that, there's slightly different terminologies, technology cooling system and I can't recall what digital equipment cooling system, I think, is the rack level. Is the rack level one?
Was it yeah.
So we need when we're here we go. So this is the loop type. So here we go. So so just as an aside, as an example, we might need to add in the DEX just so that confirms with the terminology being used within OCP.
So in general, in the OCP specifications, we've always referred to the terminology by ASHRAE. So there shouldn't be any very unique terminology in the OCP document. At least not necessarily, I think. Yeah, I'm pretty sure we harmonized pretty much everything with.
Okay, so in that case, those terms were ASHRAE terms, which means we have to align with ASHRAE. But the example still stands about making sure that we, even to that level, we align the terminology in the models. Yeah.
So just for your reference, the TCS. In this case, within the OCP, at least within the immersion community, the TCS is usually referred to as anything that happens beyond the heat exchanger that connects to a facility water system. And the TCS might be a completely built-in thing, or might be a separate thing from a cooling solution. But yeah, it's important to designate it. But there might be an additional depth. There might be a secondary TCS behind the primary TCS if there is a double infrastructure attached.
Okay, thank you. So, as I said, we need to get into that kind of detail as we go through these calls. So,
Yes, please.
I just wanted to point it out that, you know, as a perfect example of making sure we get alignment.
Yeah, this is one of our struggles because, you know, for these terms here, the primary, secondary, that's trying to differentiate, you know, when I'm looking at you know, at the world from the position of this rack CDU, you know, I have upstream and downstream, you know, inputs or outputs, and so, you know, we had grabbed that primary and secondary terminology from some product categories to try to just generically describe, you know, you know, am I receiving this cooling as opposed to I'm producing this cooling? But then, you know, as I showed, you know, in that cooling loop, you know, if you actually look then from the perspective of the cooling loop, then you have things like this loop type that would be able to describe the, you know, like, okay, specifically what am I? But again, that depends on where you're looking, and so that's why we have a lot of questions about terminology, because trying to make it obvious for everyone without using conflicting terms is a challenge.
Okay. Thanks, Jeff. Did anyone else have any questions or
Just
queries for Jeff?
I just gotta say that this is I've been to a couple of DMTF and Redfish sessions in the past. I've never had an explanation as clear as today. So thanks for that.
Awesome.
For
Thanks,
some
Jeff.
reason, I now consider myself an expert.
The previous meetings, not me then.
I'll second that remark. Well done, Jeff.
Thank you. Yeah, so and again, I absolutely encourage folks to go download that whip, and because and if you and Mick, we can also, you know, this particular document was also published individually, so you know, so we can go get a copy of that and put it on the OCP site if that makes it easier. But this is going to be by and far the easiest way for anyone on this call to look at what we've done and to start to make comments on it. So, and again, everything here is all work in progress, so it is not finalized, and you know, any input from the experts, we will make any changes that you know that are necessary, and you know, and I hope it's not a throw it away and start over at this point, but you know, the last thing we want to do is to produce something that's not usable, because that's a monumental waste of time for everyone. So it's easy to fix. It's easy to fix now. It's much harder to fix once we send it out as something you know that's intended to be finalized.
Great. So Jeff, is this a one-time presentation that you're doing in this call, or are you going to be supporting this effort?
No, I'll be supporting this effort. So I guess I should have also mentioned that. So I also lead the DSIM task force within the Redfish Forum. So we have a weekly meeting within the DMTF just on power and cooling topics. So you know, so we do try to work. You know, we're continuously working on this and trying to make progress. So but yeah, but I will absolutely be attending this meeting along with Nick. You know, as we continue to work through this and take feedback.
Okay, fantastic.
Yeah, so that actual meeting's this afternoon, so we'll have this one in the morning, and then it'll be fresh in our minds, and we'll go into the DSIM task force in the afternoon.
And for any other folks on the call that are not DMTF members, you know, please consider joining that group as well, because you know, we can operate a lot faster if we're not having to work through the external feedback portals to get large quantities of feedback in. So, but again, we're going to try to do this as much here with the experts as we can.
Okay, and like Jeff said, he did share the link so you can download this if you want to get into the details. I also shared the link for the immersion cooling IC submission, which in section 7.6 has details about how the immersion cooling was modeled late last year. So that's probably worthwhile to have a look at that if you get a chance, so we get an idea of what this looks like from the OCP's perspective. We've got a couple minutes left, so I'll just quickly talk about what I want to do next week is I want to go through and try and just from a high level model out these different types of liquid cooling units, like the cold plate, the door heat exchanger, the water side economizer, even the immersion cooling. Just make sure we capture all the different possible types, how they can be represented, whether they're embedded, whether they're standalone and relying on their own CDU, etc., and how they fit into an existing, FWS facility water system or any other existing system that it needs to plug into. So that will just be a bit of visio next week, just going through and capturing it.
Yeah, and coming from the from the systems management side, and not the product experts or subject matter on this. If I could also ask a favor, that when folks have those types of gear, boy, anything that looks like a block diagram, something that's publicly available that can show the the basic bits of piping and how things are connected and so on and so forth, and terminology. Anything at those high level diagrams can really help us to see how we can match things up and try to come common terminology for the data models.
Yeah, I did find a couple, Jeff, that I'll share with you this afternoon. Sorry, I think Ken or Herb, did you want to chime in there? I saw the mics flashing.
I'm good.
Apologies.
Okay,
So Mick, I have a question for you.
Yeah, go for it.
If you don't mind. Do you have an idea of how you want to progress the next couple of goals? Is there something that you would like to see from us as participants?
So I've been gathering stuff that I can find on the OCP and the ACF and everything, and like Jeff said, I'm trying to get an idea of the topologies and what equipment is out there. And next week I want to go through it and make sure we haven't missed anything. So, this is a cold plate and it's fed by this and it needs this, and someone might then sell a whole rack, for example, that is cold plate, and I just want to go through all these different scenarios and make sure, from a scoping exercise, that we've captured all the different topologies and equipment setup that we can before we go into the details of modelling it.
So
I'll
put some
stuff up, and I'll send out the link. I'll put some stuff up in the Google Drive, and I'll send out the links before next Wednesday.
So from experience, there might be some vendors who may have a unique approach to their management methodology.
Exactly.
Or, do you have a view on how you want to deal with those?
Well, that's part of this. I want to, if someone's, we've got everything from people who will be selling single units to people selling entire systems, right? So we need to make sure that we can capture all those scenarios. And as Jeff was saying, the model should be able to support, a single interface to a whole system down to a single interface to a door heat exchanger or a cold plate in rack system. So I guess this is the time to speak up. If you've got something unique, we're talking about it at the next few meetings. Make sure we capture it. Okay, I'm going to shut down the recording now because